Hi, this is Mrs. Kidman, and in this video, we're going to talk about how we can solve quadratic equations with complex solutions. So in our previous lesson, we discussed about complex numbers and how complex numbers are numbers that have both a real part and an imaginary part. So when we talk about finding complex solutions, what that means is we're looking for both real and imaginary solutions. Now, why is this important? Well, here's the deal. When you go on to work and you have to do calculations, we want to be able to know whether or not we're going to get a good solution or a not so good solution. A not so good solution is a solution like an imaginary number. Although it exists and it does work to solve this problem, is it going to be helpful in the real world when we're trying to build a bridge or calculate how much distance our Wi-Fi router will give us, depending on the strength that we're sending to a certain area? We need to have this idea and know how to solve for complex solutions. So in this video, we're going to talk about how we can solve for complex solutions when we use square roots to solve quadratics, when we use completing the square, and when we use the quadratic formula. You're going to notice how they're all very similar. I'm just going to do one example of each so you can see this is how we would do it and then move on from there. So let's start by taking a look at how we would solve using square roots. So first, we're going to solve by taking square roots, and that means we need to move the numbers to one side and the x's on the other. So I've got x squared equals -9. Now we want to square root both these sides here. Square root, square root. Now notice how we have the square root of -9. When we talked about complex numbers and imaginary numbers, we talked about how we can simplify negative numbers underneath square roots. So what we're going to do here is we're going to simplify this one, and it becomes -1 and 9, and then 9 breaks down into 3 and 3. And so this -1 breaks down into I and I, or our two imaginary number, or our imaginary numbers. And so really what the square root of -9 is it's actually 3i. So as we solve this, we can square root both sides and we get that x equals positive or negative 3i. So there we go. That's all we're going to do. The only difference between what we were doing before, or x squared equals 9, and x squared equals -9, is now we have that complex solution. So this had a solution of x equals positive or -3. Now we have a solution of x equals positive or -3i. That's the only difference there. So now let's take a look at how we can solve using complete the square when we have a complex solution. So let's take a look here. We get x squared plus 4x plus, remember our blank, equals -5 plus blank. And then we need to complete our square here. So remember, step 1 is to identify b, step 2 is to divide that by 2, and step 3 is to square it. So then I'll add 4 to both sides, and I end up getting x squared plus 4x plus 4 equals -1. Now this side factors into x plus 2 squared equals -1. And then we can square root both sides. Now again, we have a negative underneath our square root. We know that the square root of -1 is both I and -I. So here we go. We end up getting x plus 2 equals I, and x plus 2 equals -I. Now remember, real and imaginary components cannot combine. So as we move this over to solve for x, what we end up getting on both sides is we end up with x, oh, my pen stopped. We end up with x equals -2 plus I, which is one of our complex solutions, and x equals -2 minus I, and that is our other complex solution. So again, just like before, if we have to take the square root of -1, our two solutions are going to be the imaginary number and a negative imaginary number. Now remember, the imaginary number itself is neither positive nor negative, but we can have -1 imaginary numbers. So that is how we would do it by completing the square. The last way we're going to look at it is how we can do it using the quadratic formula. So remember, our process when we find that quadratic formula is first we need to check if it's in standard form. Now this is. Then we want to identify A, B, and C. And A here is 5, B is -4, and C is 1. And then we want to find our discriminant. So that was b squared minus 4ac. So that would be -4 squared minus 4 times 5 times 1, which is 16 minus 20, which equals -4. So when this is negative, what this tells us is that I have no real solutions. So what that means, as we see no real solutions, is that I have two complex solutions, or imaginary. And so, because technically real solutions are complex, but we have two imaginary or complex solutions here. So let's figure them out. So remember, x equals -b plus or minus square root b squared minus 4ac divided by 2a. 2a, as you guys know from that song. Okay, so we got our -b here. -b is -4, so we've got +4 plus or minus the square root. Well, I know what b squared minus 4ac is. I found that right here, of -4 over 2 times 5. So then the square root of -4, well, if we square root -4 and we break it down, we get -1 and 4. 4 breaks down into 2 and 2. -1 breaks down into I and I. So this ends up being 2. This ends up being 2i. So then we can rewrite this as being 4 plus or minus 2i over 10. And then we can actually simplify this and get x equals 2 plus or minus I over 5. And we're going to write it as our two solutions. So x equals 2 plus I over 5. And x equals 2 minus I over 5. And those are two solutions there. So again, just like before, the only difference here is that I am going to have a complex solution. So part of my solution is going to be imaginary. That's the only difference here. And really the biggest thing is, instead of it being the square root of 4, which is 2, it's the square root of -4, which is 2i. And we know that by simplifying those radicals with negatives underneath and how they become imaginary numbers. So that is how we would solve with complex solutions. If you have questions, feel free to reach out, and I hope that you enjoy this. Complex numbers are so cool, and it's so awesome that we're able to find these solutions here. Now, when it comes to the real world, if you decide to become an engineer, something like that, what you're going to end up seeing is that if you end up getting a solution like this and you get to your discriminant and you see that it's a -4, you can keep going and find these numbers. But when your boss asks what the solutions are, you can say, they don't have any this one doesn't have any pretty solutions. They're kind of ugly, because imaginary numbers, as beautiful and great as they are not always the most practical when it comes to some of the things that we're doing. So be aware of that, but it is important to know that I'm going to get an imaginary number here and decide what to do as we move forward. And that is how you solve using square roots, complete the square, and the quadratic formula to find complex solutions.